Okay. I use this. So, do you hear me? Yes? Yeah. So, thank you for inviting me here. I'm sorry I couldn't attend yesterday, but here I am. And thank you also, Mariam, for mentioning the effect-based tools in the presentation. I don't know if you discussed it yesterday already, so I have no idea. But, well, that's going to be the focus of my presentation. So I will talk a lot about a previous activity under the working group chemicals related to effect-based tools and a technical report, but also a little bit about future prospects. Okay, this I should not. No. This one, maybe. Ah, there it is. Okay, thank you. So, why effect-based tools? Well, is it this one? Yeah. So the traditional ways within chemical regulation and Water Framework Directive is to look at chemical analysis and establish EQSs, environmental quality standards, but also look at trends, and this is sort of the drivers for undertaking measures, program measures. Analyzing chemicals is a risk-based approach, and you also catch secondary poisoning, this illustration, and also can cover human health issues. But as we have discovered that the list is getting longer, so which substances should we include? There's also the concept of bioavailability, to take this into account. That's a problem when you interpret the results. And also the focus here, combined exposure, the mixture effects. So the effect-based tools, there are generally two types, we could say, or actually several subtypes. But what I mean with toxicology tools is like bioassays, biomarkers, and so on. And ecological tools is rather that you look at community structure and function. They're of course very interrelated, but we use all different terminology and just to explain that. So when you have toxicological based tools, you can capture, they're also risk-based sort of. They can capture combined exposure, and they also, in part at least, they can tell you something about the bioavailability of compounds. But then there's a drawback, which also highlights often in this context is, okay, what to do about it? Which stressors, which compounds should we try to regulate? And how can we assess human health issues and secondary poisoning with toxicology-based tools? Ecology-based tools are pretty much the same advantages, but in maybe less risk-based because the effects have already occurred, sort of. And again, what do we know about human health issues and secondary poisoning? So this report, it's a technical report. It was published in 2014. And there were many, many co-authors, and some of you are here, I can see. So I really wish to thank everyone for their contributions. It was a work, I think we were working on this report from almost 4 years. It took some time. And there's actually two reports, we could say. That there's the main report, and there's also an annex. And you can download on the Circa website. So the aim of the report is to describe state of the art of aquatic monitoring tools, effect-based monitoring tools. Just a very short, of course, please read the report, but just short about the content. So in the main report we have chapters on different type of categories of tools, on bioassays, and in the terminology we use here is that you measure the toxicity of environmental samples. Biomarkers is a little bit the same, but you measure on field-exposed organisms, sort of, you check the organism. And ecological indicators. They're more on higher organizational levels. Right. So, the in vitro tools, the in vitro assays, some general aspects, of course, there are many different types of tools. They're related to a certain mode of action. For example, you can monitor estrogenicity, dioxin receptor activity, and so on. The results are not always, but generally anyway, expressed as chemical equivalent basis. So you have it expressed more or less in the same way as if you were doing a chemical analysis, but it's recalculated sort of into one chemical. There are standards available for some of them at least, and to sum up, the advantages is that usually low cost, small scale, short duration, and so you can more or less also analyze any type of samples. It a little bit depends on what type of analysis you're talking about. So they're good for high throughput applications, for screening, for surface water and effluents, for example. So in the report you can find tables with different type of tools, more information, and also we have focus, of course, on the use for surface water monitoring, but some points are also discussed when you use them for effluents as well. So, and the next type of tools are in vivo assays, which I think are all familiar to you because they are the traditional way, traditionally used within chemical regulation. So there are a large number of standards available, but they're primarily developed for chemicals testing, of course, but are used in different contexts. For example, mentioned in other guidance documents to assess toxic pressure and to confirm whether you have problems in sediments, for example. So, and biomarkers are pretty much related to in vitro tools, sort of the same thing you measure sometimes, but there are different types of tools here too. You have biomarkers that are more early warning, exposure biomarkers, or effect biomarkers that are more ecological relevance. I'm not going to go into details here, but there are also some biomarkers that are more specific, that you more or less know which type of substances you're monitoring, and some biomarkers that are more general, that cover more substances and pressures, and also other types of pressures, not necessarily hazardous substances. So what we usually see is that the conclusions in literature is that batteries are generally better to combine several tools, and also a concept of integrated monitoring, because you take fish samples, for example, you can monitor both chemicals and effects, the biomarkers on the same fish, more or less. And if you combine it with in vitro assays, you have a tool to actually identify causes. And this, of course, also described in more detail in the report. Different types of tools, what kind of substances they respond to, if there are assessment criteria available, and so on. So, and Werner, you're here. So, also a chapter on effect-directed analysis. If you really need to know which substances are behind the observed effects, there are ways to deal with it. And we describe it also in the report. So it's more or less about fractionating the samples and rerun your analysis and make it smaller and smaller fractions and try to identify. And normally, well, I wrote causes also because sometimes it's not so easy to identify one single substance. It was one single substance, but rather a few or more. But of course, if you want to do this, it's necessary to be able to use high throughput, short-term tests, of course. but it is possible. And then finally, the third type of tools, the ecological tools, are also described. The problem we have, because in the Water Framework Directive, we call it biological quality elements. And they're all in there and possible to register. But in 2012, there was an inventory of all these tools, and they found 4 available registered tools that could actually be linked somehow to hazardous substances. So there is a lack of tools here that are in use, in routine use, in regulation. And I heard you already talked about PICTs, I'm not going to mention, but of course there are other tools as well, but they are not yet registered anyway as these type of tools. And, well, the annex is also quite a large document, but for interest to this group, maybe a list of biomarkers and inventory assays combined with type of mode of action could be of interest. So the report was also there to identify are these tools used today, and for what purpose? Why are people using them already? Because they are usually not required, but still they are used in some countries and in some contexts. So, and one major use is to characterize complex mixtures, to assess pressures and to help with risk management. So whole effluent assessments, for example, whole effluent analysis, that's a common use. Not in every country and not in every context and not maybe on a regular basis, but it occurs. For dredge sediment, they are used in some countries on a routine basis. For contaminated sediment sites and so on, they have been used. And why? Yeah, they cover many substances at lower cost sometimes. So some of these, like in vitro assays, they are also used within screening tests. When you want to look at you want to find emergent substances, for example. So estrogenicity is in use actually in Sweden. I think every year, annually, we're applying these tools on a number of sewage treatment plants. But also more in general, and this has been in use for a long time on a regular basis in some countries, especially in the marine environment, the biomarkers within OSPAR and also HELCOM. And some other contexts. So in this context, we use them primarily perhaps as early but long-term warning. So it's like trend studies. And in this context, it has already been put into the Marine Strategy Framework Directive. And in Holland, for example, they also use effect-based tools as an alarm system to have an indication about it for drinking water safety. So if they have a continuous toxicity test, I would say, to see if there is an effect, and then they immediately close the water intake and check, is there something in here? So that's also early warning, but very immediate warning. And of course, a little bit like this, that you identify regions with lower quality areas. So a little bit about whole effluent assessment, because it's actually not so well covered in the report. It is measured in a few of these VAT reference documents. This is from the monitoring document, for example. So with toxicity tests, it's possible to assess the possible hazardous character of wastewater in an integrated manner and to assess all synergistic effects which may occur because of the presence of a lot of different single pollutants. Also to protect or optimize biological wastewater treatment plants when used in combination with direct measurements of specific substances and with measurements of some parameters are increasingly becoming a set part of any whole effluent assessment strategy. This is from 2003. And this is from the Cohiba report 2010, which focused on HELCOM use in HELCOM countries. And they are, well, unfortunately, controlling whole effluent toxicity or combined effects is not a common practice. There are a few exceptions. In Germany, there are legislation where they set whole effluent toxicity limits. In Sweden and Denmark, there are guidance documents. In Finland, it has been applied in a few environmental permits. But still, it's not, well, it's used, but that it could probably be used more. But of course, we need to look at what type of tools. So this is from an OSPAR guidance document on whole effluent assessment, different tools, how they are used in different countries. And one question, what is, like I said, it's been raised as a problematic issue for toxicity or effect-based tools, is that how can you regulate the effluents or the emissions if you don't know which substance it is. But actually, from the QIBA report, they also checked in different countries how they actually regulate the effluents if they have used toxicity tests. So a common way is to express an emission limit value as an effective concentration for a certain percent. So if it's 50-20%, it means 50% of the testing orders were affected when the effluent concentration was 20%. So this is very similar to the way we can express PNEX for chemicals. You can also regulate no observed effect concentration. In Germany, lowest ineffective dilution. In the US, toxic unit is very common, and so on. A little bit similar approach for dredge sediment. This is from Norway, so they have a few in vivo tests, plus if they suspect dioxins, you can also run an in vitro test, and they have a threshold level for dioxin effects. So to summarize, the current regulatory use is perhaps primarily whole effluent assessment, dredge sediment, and so on, but in combination. Toxicological tools are not replacing, but in combination. So suspected listed substances are the common practice, I think, in combination with toxicity tests. On the receiving water, I mean in the surface water, again, suspected listed substances and biomarkers and bioassays, they are used. On emission limit values, well, this is the most common way to express the emission limit values on a concentration basis or amount basis, but also this is sometimes used. So, can they be used today within the current Water Framework Directive language? Sort of, do they fit in? So this was also part of the report, to try to identify where do they fit in. So what we found was that, well, within pressure and impact assessment, they're useful because they have been used as screening tools and early warning. So this is a way to help identify priority areas where you should look further. To support compliance checking, because they are mentioned also already in some earlier guidance documents on like a step 2, when you have found concentrations above a certain threshold level, but you don't know about the bioavailability. So this could be a way to try to focus on that. But of course, in the Water Framework Directive, we're not only talking about priority substances, but also river basin specific substances. So it would be possible, I don't know if it has been used, but it would be possible to identify new interesting substances on a river basin on a local scale. So this is sort of to fit them into the Water Framework Directive language. So identify pressure, assess risk. They are mainly mentioned in earlier guidance documents. To assess status, well, they could be supportive, but they're not sort of there are no EQSs for them in the directive. So, in the Marine Strategy Framework Directive, they are mentioned sort of, because Now the Commission decision on the criteria is under review, but what it says so far is it would fit under criteria 8.2, because you should assess not only the concentrations but also the effects of contaminants. So in Sweden we already have a few of them in our regulation, some of the effect-based tools. And here actually a little bit interesting, because so far we have, for example, indicators for on sea eagles. So it's also for birds and marine mammals. So this is sort of a way also to assess the risks from secondary poisoning. So my last slide. So what are we going to do now then? We have the technical report, and Stephanie, I don't know if she's here today. There you are. I guess you talked already a little bit about this yesterday. I'm not going to tell so much more, but anyway, we already, I think, pretty much have a toolbox, but we need to check what we have, which tools are best for which purpose and where and when and so on. Be more specific and sort of recommend this is good for that, but maybe not for this, sort of to try to more recommend. So what we're going to do in this activity is to look at different mode of actions of different compounds, relevant mode of actions in this context, try to select and prioritize between all these tools, and look at also the trigger values, because it's sort of necessary if you want to evaluate it. And also look at these ecological methods, because there are some. There are some upcoming to try to look for them, to see where and when, sort of. And also try to harmonize the assessment. Would there be a good way to harmonize Water Framework Directive and Marine Strategy Framework Directive to see how this could fit together? And also very important, I think, because what can you do about it? This is a very common question. If you found effects, what can you do? How can you control? And of course, how much does it cost? It should be a cost-effective approach, of course. We don't want another long list. So finding a good combination and a good effective approach. That's what we are aiming at anyway. So I tried just to write maybe this, but that's for discussion. Yeah. So, thank you.
Yeah, thank you very much for this.